Hello and welcome to the Data Engineering Podcast, the show about modern data management. When you're ready to build your next pipeline, you'll need somewhere to deploy it, so check out Linode. With private networking, shared block storage, node balancers, and a 40 gigabit network, all controlled by a brand new API, you've got everything you need to run a bulletproof data platform. Go to dataengineeringpodcast.com/Linode to get a $20 credit and launch a new server in under a minute. And are you struggling to keep up with customer requests and letting errors slip into production? Want to try some of the innovative ideas in this podcast but don't have time? Data Kitchen's Data Ops software allows your team to quickly iterate and deploy pipelines of code, models, and datasets while improving quality. Unlike a patchwork of manual operations, Data Kitchen makes your team shine by providing an end-to-end data ops solution with minimal programming that uses the tools you love. Join the data ops movement today and sign up for the newsletter at datakitchen.io/DE. After that, learn more about why you should be doing data ops by listening to the head chef in the Data Kitchen at dataengineeringpodcast.com/datakitchen. And go to dataengineeringpodcast.com to subscribe to the show, sign up for the mailing list, read the show notes, and get in touch. Your host is Tobias Macy, and today I'm interviewing Jonathan Katz about a high-level view of PostgreSQL and the unique capabilities that it offers. So, Jonathan, could you start by introducing yourself?
Sure. Thank you, Tobias, and thank you again for having me. So my name is Jonathan Katz. Currently, my role is I'm the Director of Communications at Crunchy Data, which is an enterprise Postgres support company. But I'm here today talking about my role in the Postgres community as a contributor. I guess, just a little bit more about my background. Before I got into this marketing position, I was actually on the engineering side, and I've basically been programming for about 20 years. Mostly, I was active in the New York City tech startup scene in various leadership positions. Previously, the CTO at a company called VenueBook. And a couple of years before that, the VP of engineering at a company called Paperless Post. And of course, at both companies, I was using Postgres.
And before we get too far along, can you help me settle the pronunciation debate of how is it that you're actually supposed to pronounce the name of the database?
Yeah, so that is a good question because it's not only the pronunciation but also the spelling. So the commonly accepted ways to pronounce Postgres by the community are Postgres, as I've been saying, or PostgreSQL. I've heard things like PostgreSQL, PostgreSQL, and some weird intonation on that, but it's Postgres and PostgreSQL.
And do you remember how you first got involved in the area of data management?
Yeah, so I think it actually started when I was a teenager, when I first began developing websites. I found I was doing what I learned was a very common mistake where I'd be repeating my code and basically doing the same thing over and over when trying to get certain lines of data to render. And even being a naive 13-year-old, I kind of thought there was a better way of doing that. So I started researching databases, and this was back around 2000 2001, and one of the common stacks back then was the LAMP stack, and Linux, Apache, MySQL, and PHP. And this, basically what I got started with was first a MySQL database. And I learned from some friends that this is other database called Postgres, which is how I began using that. But what really fascinated me about data management and data engineering was how much you could do with data. That once you had it in this structured database, all the different kinds of analyses that you can run. And I also became very interested in machine learning. And this was more when machine learning was in the research phases as opposed to how widely commercially deployed it is today. And of course, what you need to do for machine learning, you need to not only store a lot of information, but be able to analyze it as well. And I began to see how useful it was to use databases to do so. And I think, the other thing is I just love programming. I love programming languages, and learning SQL and just all the different things you can do with SQL, particularly within a Postgres database, just made me, very excited to work with it, create reports with it, create generalized reports that anyone can run, and really see how much you could do with that kind of information. So I think, it's, the way I usually summarize it is that I've just always been fascinated with data and everything you can do with it. And it's just amazing to see, since I started 20 years ago, to see how much just the field of data management has evolved to what it is today.
And do you remember how you first got involved in the Postgres project itself and became one of the core contributors and actively involved as one of the maintainers of the project?
Sure. So first, I would say, my role, and there's actually something called a core team, and I'm not a part of that. But the way I became involved in Postgres was, first starting out as a user of Postgres, and I like to think of the Postgres community as everyone who's either using Postgres, contributing to Postgres, developing Postgres, whatever it may be. And when I first started using Postgres, I just really liked all the functionality in the database, and I think that's something I definitely would like to talk about a little bit later. And I want to figure out a way to be more active. I mean, I think one of the wonderful things about open source is that the community of giving back. That if you're using something, you should try to find a way to contribute. And when I looked at the people who were active Postgres contributors, they were just brilliant engineers. They're adding very complex features that were very stable and very performant. And I felt that I could be more useful in being involved in helping to organize events and organize ways to help promote and educate people about Postgres. I initially started by helping to organize and grow the local New York City Postgres user group, which today is the largest local user group in the world. Back when I started, it was maybe about 60 people. From there, I became active in conference organization. I had organized entrepreneurship events when I was in college, so I had some familiarity with it. Once I was out in the professional world, and I helped to grow some very large Postgres events. And of course, the nice thing about Postgres is that it really is a team, and everyone helps and supports each other. So, having that great support network, working with all these wonderful people has been great in terms of helping to grow that. And since doing the conference work, I'm now helping more of the general project advocacy. So if you read any of the press releases coming for the Postgres project, I've probably been involved in writing those. I also help manage the website. I was involved in a project that just redesigned the Postgres website, which had not been updated since I think 2004. So having that more modern look and feel certainly, I think, should certainly help the project. And also, I do enjoy speaking. I mentioned to you before we started, this is my first podcast, but frequently I'm doing public speaking, at various local user groups, conferences, events, etc.
And for anybody who hasn't used or directly interacted with a Postgres database and the project itself, can you briefly describe what PostgreSQL is and what differentiates it a bit from some of the other relational databases that are out there?
Yeah, sure. Well, I think actually a good way to start with that is to give a little bit of a history of the project and how it came to be. And, I mean, first I'll just say Postgres is what's called an object relational database management system, or also known as an ORDBMS. This derives from a relational database management system, which is what most people are familiar with that term. And, and basically that's what Postgres is as well. But it all goes back to a paper written by Edward Codd called A Relational Model of Data for Large Shared Data Banks, which was the definitive guide for how to build a relational database management system. Basically, what it did was that defined what data was and various attributes around how you could classify and store data, as well as something called relational algebra, which is the language to which, the mathematical language in terms of how to manipulate data. And you can basically trace every single relational database back to that paper. Um, so for example, Oracle is implemented based upon the information given in that paper, and Postgres is no different. Postgres came out of a project from UC Berkeley from a gentleman named Dr. Michael Stonebreaker, who's been prolific in the database world. It's simply Postgres means post ingress. That's where the name originates from. Ingress was a database Dr. Stonebreaker had worked on prior. It was Ingress, and I don't know as much about it as I would like, but it was a lot of it had to do with image processing. And Postgres wanted to extend upon the relational database management system by implementing these things called objects or types, which this is where a lot of Postgres's power in terms of manipulating data types comes from. So basically, Postgres was first implemented in 1986. And ultimately, what happened was that several iterations of it were made. At this point, it was closed source. It's just it was part of a university project, and eventually it was commercialized and picked up by a company called Illustra. Which just a little bit history of that was that Illustra eventually was merged into Informix, which was then later acquired by IBM. And several versions of Postgres were created, and but again, it was still either in a few commercial companies or as part of this academic project. The big breakthrough for Postgres in terms of becoming open source happened around 1995, where two students at UC Berkeley, Andrew Yu and Jolly Chen, added the SQL language to Postgres. This was actually a very big deal because if you looked at database management systems up until that point, all of them implemented their own unique languages. And Postgres was called Quell, Quel. And there are different languages for the different systems. And what made this, by implementing SQL, which is what the data management community was trying to standardize around, it made it easier to access Postgres. And it made it easier to have a career in data management where instead of needing to know 10 different languages, you only needed to know one. This was released to the web as Postgres 95. Basically to commemorate the year it was released. And of course, looking back, that's when Windows 95 was out, and a lot of things were giving that 95 moniker. And also, the other big deal was it was released to the web in 1995, and is recalling the web back in 1995 is a very different landscape than it was today. And you typically did not release software to the web, like free software for people to download. This was relatively novel. Linux had only been released, I think, a couple of years back. So what happened was, the other thing I should mention is that, in addition to standardizing Postgres around the SQL language for interfacing with it, it was rewritten in ANSI C, so a standardized version of C, which would make it much easier for other people to contribute and develop it. So some others became very interested in this project, and they wanted to open source it. And on July 8th, 1996, though, actually I looked it up, it was July 9th UTC, 1996, several individuals committed Postgres to the CVS repository. It was renamed PostgreSQL at that point. And I know I'm still going to refer to it as Postgres because it's a little bit easier to pronounce, but from 1996 onward, it was known as PostgreSQL. The license I was chose to open source it is its own license, the PostgreSQL license, but it's based on the BSD license if you're keeping score at home in terms of that. And the other thing that really fascinates me is that when Postgres was open sourced, it already had 10 years of development behind it, and 22 years later, it's still being developed. So there's already 30 plus years of development on PostgreSQL, which is a really much of a testament to the community behind it developing it, and also the power of good software architecture. That if you do write something very well, it's easy to continue building on top of it, for many years to come. So in essence, just to circle back, what is, if I describe what Postgres is a database at its heart, but it's a database that has a lot of functionality.
One comment out of there right off the bat is, as you said, it's a 30 plus year database project or software project in general, which for anybody who has worked at any length in the software industry, that's quite a commendable accomplishment, because I know I've written software 2 years ago that I don't even want to look at anymore, let alone something that's 30 plus years old. And I think that your point of the object aspect of the Postgres relational system, of being able to have custom types and support more than just the standard primitives, is one of the things that has really granted it staying power, because it does have so much adaptability for various use cases without the core team having to be the ones to maintain that functionality out of the box. Is one of the things that really provides a lot of the power and a lot of the innovative uses of Postgres that I've seen in various contexts. And so, yeah, digging a bit more into some of the primary characteristics of the Postgres project, what are some of those that would particularly lead someone to choose it over another relational or even non-relational database system for a given project that they're starting to architect?
When I listen to this question, I think a lot about my experience as an application developer, where while maybe the application I was crafting might have been written in Python or Ruby or what have you. I mean, it all came back to what can the database offer, as all these applications were database driven. And this is with my computer scientist hat on. For me, it always starts with the data types. Like how can I store my data? What can I store my data as? And you talked about the primitives that Postgres has. And even if you just look at the basic primitive support, I have an introduction to Postgres training for data types, where I spend just an hour on the primitives. And these are the numeric types, the string types, and the things like that. Because there's a lot of different indexing capabilities around it, which I do want to touch on in a little bit. But there's a lot of functions that really let you harness the power of just basic numbers. For me, it really starts getting interesting when you get to some more structured types. And one of the things that's really helped me throughout my career is Postgres datetime support. A lot of the core functionality for Postgres's datetime support was completed about 15 years ago. It really, is a testament to the engineers behind it. But for one thing, it's very easy to do date and time calculations. It's very easy to manipulate intervals, do relative date calculations based on that, and also the time zone support. It's very easy to convert between the different time zones, which is the bane of every schedule manager's existence. You're trying to figure out when to organize things. Additionally, the indexing around the datetime support is incredible too. Now, I've had to do a lot of work with scheduling throughout my career, and I've always been able to fall back on Postgres to ensure that I can both accurately and quickly store and manage the data around dates and times. Another structured data type I love is the array type. Postgres can store arrays, and you kind of think about that. Well, isn't that against the relational database model? And well, yeah, it is, but also we need to be practical too. The way that Postgres handles data type compression, there's often cases where it makes more sense to store information in an array versus in a series of rows. Additionally, the array type, based on Postgres's object typing system, the array type works for essentially any type that's in Postgres. So you can have an array of integers, array of dates and times, array of more complex objects like XML documents. You can have an array of arrays. You can have an array of arrays. So it's very flexible in that. One of my other favorite structure types is the range type, and that's definitely helped me, in scheduling type applications. So Postgres allows you to store ranges, ranges of times, ranges of numbers, which have applications, not just in scheduling, but in science, storing things like error bounds, probability, and other things where range data is very important. What makes it useful is not just the storage around it, but the indexing, which I keep alluding to as something I'm going to discuss, which I will. I just want to be able to tie all the different data types together. And things like UUIDs. And I know there's a big debate in the data management world, like, do I want to use UUIDs? But the fact is Postgres supports them. So if it makes sense for your use case, you can do that. Document types. Postgres has gained a lot of buzz for supporting JSON and its binary formatted JSON type called JSONB. But before that, Postgres actually was able to store XML documents, and you could do a lot of introspective work around those, and as well as generating them, as well as it had its own key value based data type called HStore, which actually predated JSON when you look at the history of key value storage. Postgres has a lot of built-in geometry types as well. You can store points, lines, circles, polygons, and extended upon that is a geospatial extender called PostGIS or PostGIS, another tool that you can debate how to pronounce the name. But what PostGIS does is that it stores you can store geographic types and geometric types that are used in mapping, and it's actually a tool that's widely deployed and widely used in commercial spaces. And as you mentioned earlier, Tobias, there's also custom data typing. You can write your own data type. You can write within Postgres. You can write a C extension to do it. Whatever you feel most comfortable with, as well as building out composite types. So I think what I'm getting at is that there's a lot of data type support out of the box, and it's very easy to store structured information in a way that's easy for an application developer to access it. Of course, as I was going through that, it's one thing to store information, it's another thing to retrieve it. And in order for these data types to be useful, you need to be able to search over them, particularly quickly. And Postgres offers many ways of doing that with indexing. Most relational databases implement something called a B-tree index, which doesn't actually, everyone thinks. I always ask, what does B-tree stand for? And people say, oh, balance tree. And I'm like, no, it actually stands for B-tree. It's not abbreviated for anything. So, but what a B-tree is, it is a balance tree. And, it makes it very easy to do equality and, inequality operations to be able to search through data, within an index. Postgres goes beyond that with its standard B-tree index, where it's able to handle, multi-column indexes, expression indexes. So if I want to index over an immutable function, I can do that, which you can see is very useful in looking up things like all lowercase email addresses and the like. Postgres also supports something called a partial index, where you can index only over a subset of the column by adding a where clause to the index. For instance, it's very useful if I have a if I'm partitioning, let's say I'm partitioning my information by active or inactive, and I want to make sure I can quickly look up all the active information in my table, I would probably use a flag at the end of an index saying, index this ID where active is true. Now, the B-tree index is great for the primitive data types, but when you have things like, let's say, geometric shapes, it might not work. Why is that? Well, if I want to say, look, find me all the squares that are equal to this square, what does that actually mean? I mean, I could probably look up squares that are equal in area, in which case I would put an expression index on my column containing squares. But that's not necessarily useful in a geometric query. Geometric queries, particularly in mapping, it's more about, am I overlapping with a space? Am I within a space, and things like that. So the Postgres community added an index to handle this called the generalized search tree, and this was set up to handle different arbitrary indexing schemes. One of my favorite features of the gist index is something called a k-in gist query, or a k nearest neighbor lookup. These are useful for finding things that are close to you, like find the 5 closest coffee shops to where I'm standing. Those indexes, one interesting thing about those is they take a little bit more time to set up because it does have to store a little bit of information, but it makes these kinds of geospatial and geolocation queries very fast. The gist index you can also see being used for arrays and ranges, and particularly it's used very heavily by PostGIS. It's it's definitely it's a very powerful, flexible index. It's still a tree-based index, so you would like it to be relatively balanced. But there's an indexing type called spgist, the space partition gist index, which is better for unbalanced data. spgist was introduced, I believe, in Postgres 9.3 for dealing with unbalanced range types. And it's something that I've used, and it works very well if you have data where it's not going to fit your normal balance of where you see in a B tree or a regular gist type index. Another one that's very helpful is the GIN index, which is the general inverted index. Sorry, I'm going to say that word again. It's the general inverted index. GIN was introduced to help primarily with full text search within documents, which is actually, if you the full text search documents have their own data type as well, I should mention. It's also used for introspecting JSON documents. This is where we get the very fast JSON-B queries. As well as has some support for arrays as well, being able to introspect elements within integer arrays. Another useful index is the BRIN index, the block range index, which was developed for looking over information in very large tables. So if let's say you have a table that has 1 billion rows and you're storing integer data and you want to be able to narrow down fields quickly, the BRIN index is designed to quickly get you to the set of rows that you want. It's actually very space efficient as well. Yeah, so maybe to tie it all together, what makes Postgres work so well, just fundamentally from an application developer standpoint, is this data type support and this indexing support combined with all the functionality that you can get around manipulating and introspecting data types. But this is just the tip of the iceberg. A lot of the other features that are very important in Postgres, are around what you would say is keeping your data reliable and safe. Postgres implements a concept called write-ahead logging, which basically records every single change that's made to your database. And this is important because it gives you a playbook for what is occurring in your database. And in the case of disaster, you can restore your database back to a particular point in time, also known as point-in-time recovery. Since Postgres 9.0, when native streaming replication was added, there's been a lot of different functionality added around improving, different ways you can copy your data from one Postgres server to another. It could be done asynchronously, which is a very fast operation, saying, all right, I've written this data on my primary, send it off to all the standbys, and I'm done with it. It could also be synchronous, where I could say, all right, I've written this data to my primary. Now write it to the standby, and don't say the transaction's committed until it's been marked as committed to the standby. Since Postgres version 10, there is Logical, which allows applications to connect to Postgres and read in all the different transactions and decide how those applications wish to handle them. Logical replications also could be very important in doing online upgrades in versions of Postgres after version 10.
Yeah, so the point that you made about it being very useful from an application development perspective because of all the different data types and indexes and custom logic that you can embed directly into the database provides a lot of value. And one of the approaches that a lot of application developers make is to try and treat the database as just dumb storage and not leverage all of the features of it, which helps with portability of the application, but you end up hamstringing yourself in terms of a lot of the performance gains and additional utility that you can get from your storage layer. So it's definitely worth investing the time figuring out what is available and taking advantage of it and potentially tying yourself to a given storage engine, particularly if it's something like Postgres that has been around for so long and has such a proven track record of stability and performance and functionality. And so, given all of those reasons why Postgres is so useful and the many besides that we haven't even begun to touch on yet, what are some of the cases where Postgres would be the wrong choice, where somebody should look at different storage options for their data?
Yeah, I think it becomes very application specific at that point. And and also making sure that you're basically using the right tool for the right job, which is a common engineering mantra. Some cases that I've heard of, well, I should say one area I've seen Postgres used less is, at present is embedded devices. I've seen some talks, I've heard some cases where people have run Postgres on embedded devices, but quite often it might be good enough just to use SQLite, which is, it's really optimized for, some of those, those small devices and the use cases that are around those. There's also been some public quote unquote performance issues or other cases where so and so company has stopped using Postgres and used another solution. Of course, you've seen just as many in the other direction as well. But the reason I want to touch upon that is frequently when or often when you see a report like this do come up, the community is really wants to understand like why this happened. Was it a configuration issue? Was it just lack of understanding of using Postgres, or was it something that was wrong with the database that needs to be corrected? And really, in all three buckets, the community tries to make improvements. If we realize it's an awareness issue, like what can we do to better talk about what the capabilities are of Postgres? If it's an architectural or development issue, the community typically will work on fixing that issue, and you often see that these issues that do get talked about that are actually engineering issues end up being fixed, often in the next version. There are some, there's some more, I would say, things that Postgres could definitely do better. I mean, right scaling is still something that it's been improving in subsequent versions of Postgres, and you can see some improvements for that coming in Postgres 11 with the improved partitioning work. And there are also some tools and extensions to help with right scaling, but natively it's still you don't have a parallel write mechanism yet in Postgres. The other thing is people will often look at who can support Postgres, how many people are working on it, and this is a problem that has been gradually going away because we have more people contributing to the Postgres community in addition to more people just using Postgres. So you have this general community expertise just amongst all the different users. So it becomes less and less of a reason to not use Postgres. Then there are certain things where Postgres is probably not the right solution. If you're looking at high speed messaging or being able to communicate very rapidly between applications, you might want to use a tool like Kafka, which is or other asynchronous message brokers and tools like that, which is definitely something that I've done. So again, like I said, it really becomes application specific. I think when you want to make sure that your data is stored and there's essentially like a centralized data repository or even a distributed data repository where my data is stored here, I can always get it out. That's typically where Postgres, you end up using Postgres, and that ends up being a very large swath of applications.
And one of the points that you made there of why people have historically chosen to move away from Postgres and use other platforms is the potential for confusion or misunderstanding, whether it's in terms of how to deploy and manage the database or configure it, or how to use it at the application level. So, what are some of the most common points of confusion for people who are new to Postgres, particularly if they do have prior experience working with other relational database systems?
Yep, and and that is a very good question. So one of the things that has been improving in the Postgres community, but can still get better, is I'd say ease of use and having user interfaces that are friendly, that are easier to set up Postgres databases, interact with Postgres databases, and do a lot of tools that, or basically do the functionality of a lot of tools that you see in, let's say, the proprietary software world. There's a very good project called pgadmin, which has been around for a while, and that's continuing to improve. That helps with a lot of the database management functionality, and it is a very popular project in that regard. But it does focus primarily on Postgres itself, and as we mentioned earlier, Postgres is very extensible. Tools like things like backing up. Postgres does have backup capabilities, but there are more powerful tools that are extensions to Postgres that are better for large scale type backup solutions. So once you come into the Postgres community and you see that there's all these extensions, it could be very overwhelming, and that sometimes the right tool is not bundled with the core Postgres software. Especially talking to, let's call them ex Oracle DBAs, that's where they'll trip up the most, because they're able to navigate around a command line, or be able to write very complex SQL, but not having everything right out of the box can be a little bit overwhelming. And I think that's an area where I do see us continuing to improve. And you typically see that if there's a tool that the community coalesces around, that it might be able to make it back into the core software. The other thing is the Postgres community tends to be very command line driven. And by that is like we don't use user interfaces as much. Especially the people who've been around a very long time. It's writing code in Vim or Emacs, or even just I know some community members still read their email in text-based editors, from the command line. So there is a lot of comfort with just using the command line in Unix-based tools. Well, coming from some other database platforms, there might not be as much comfort from doing that. That's typically where you see a lot of confusion. Is that, and maybe the last point, because we only just started touching on the functionality of Postgres. There's so much within Postgres. I mean, I can tell you, I've been using Postgres for 15 years, and while doing some research for our discussion today, I learned some new things that I did not realize Postgres did. So even for veterans of Postgres, you're constantly learning more and more about the functionality of the software, and that makes sense too. I mean, the code base is over 1.1 million lines of C code. There's a lot going on there, and sometimes it's hard to keep track of everything. Fortunately, Postgres has phenomenal documentation, so you can look it up, but you still also need to be able to know what you need to look up as well.
Yeah, that's definitely one of the things that I've bumped up against occasionally, is not even knowing what to search for. But then when you do figure it out, as you said, the documentation is very extensive and descriptive. And also, the overwhelming number of potential configuration options can turn somebody off who's coming from maybe a more straightforward database engine where they don't have to do as much tuning, or it's optimized for the default use case that everybody uses it for, whereas Postgres has a good set of default options, but there are so many different ways that it can be leveraged, and there are a multitude of parameters that can interact in not necessarily very obvious ways. So once you go beyond the default of just reading and writing to the database and trying to tune it for a given workload, it can become very time consuming to research all of the ways that you can tune the database. So somebody might decide to just go back to their default choice of a different engine rather than actually figuring out all of the ways that they can optimize Postgres for their application and then be able to leverage it to a greater extent than they would their prior engine.
Yep, and you hit the nail right on the head there. I mean, let's just take an application where I might write once and read many times, but it's a relatively small database, or a database where I write once and read many times, but it's an OLAP data warehouse style database. I would tune both of those databases very differently, and I mean, of course, I would architect those databases very differently as well. And then take a write many times, read seldomly. I would architect and tune that database very differently than those other two. So three very common use cases right there, and three very different configuration sets.
And just very quickly, for somebody who is interested in digging deeper on how to tune Postgres for these various workloads, what are some useful resources that you would recommend they check out?
Yeah. So on the Postgres documentation, there is some guidance in terms of how these parameters work. Also, on the Postgres website, there are some support resources that will link to either channels where you can talk to people who have these kinds of workloads and can provide advice. Also, some other online resources and presentations that offer up these as well. Attending local user groups is another great thing too, because I would actually say at NYC Pug last month, we had a speaker, Payal Singh, who talked about exactly this, like how do you tune Postgres, how do you optimize it within a Linux environment, and talked about a lot of these different settings. The thing that makes data management so challenging is that it really can vary based upon your workload and the environment in which you deploy it. Like, is your database within a cloud environment? Is it on bare metal? Are you in a private cloud where you're controlling all the resources around you? Are you in a public cloud where you have no idea what's running next to you? Because that will affect in terms of how you might want to tune some of these parameters or handle some of this architecture. And then beyond that, it's how am I storing the data myself? Is there a particular table that I am reading and writing to much more than another one? Is there a table that it's easier for me to federate it across multiple Postgres databases because of whatever architecture I'm planning, or how I'm actually writing this data to the database? So it becomes so subjective, and this is kind of the art of being a Postgres DBA. The good news, is that there are resources to do it, and you find the Postgres community is very helpful. Two popular ways to get some advice on this, near instantaneously, are the Postgres IRC channel, hashtag PostgreSQL on Freenode, and the Postgres Slack channel, which is also a well, I forget if it's a hashtag or not on Slack, and I'm actually on that channel. But there is a community PostgreSQL Slack channel where people are happy to help. But yeah, probably the best way though I find to get particularly performance advice or get caught up to speed on it are at the Postgres conferences, the Postgres community conferences, because you're guaranteed to have someone who will be discussing that topic, and you're also guaranteed to have people there who are very familiar with performance tuning as well.
And in some of the most recent releases, there have been some very substantial improvements and new features added. And given the fact that Postgres is used in so many very performance intensive and very critical environments where you need to ensure a high level of stability and reliability in the data layer, what are some of the strategies that the community uses to manage that balance as they update and improve the database for new types of workloads and environments?
Well, first, I'm glad it appears that we're making substantial improvements. That's always good to hear. And that's very good feedback for the community. I think the first thing is the community ethos in terms of maintaining that stability and security of the product. I mean, the community understands that data is one of, if not the fundamental part of any application out there. I mean, it probably sits just above the operating system in terms of the part of the system that you need to be the most stable. If your data gets corrupted and is unrecoverable, I mean, that could be the end of your business. So the community does adopt that mindset and ensures that, and does its best to ensure that everything that's written is and released is going to be as stable as possible. You will see, you see in the community as well, if you follow the PGSQL-hackers list, the debates that will go on, sometimes even one-line patches, but ensuring that whether it's one line or 10,000 lines, that it's not going to affect the overall stability of the system. Features will not make it into Postgres because people think it's going to affect it's going to affect the overall performance and stability of Postgres. You'll see some features. Sometimes it takes years for them to get in because the community really wants to ensure that that code is going to match Postgres' reputation for being stable.
I remember following the saga of the upsert capabilities in Postgres and waiting while the debate raged on as to how best to achieve that.
Yeah, and again, it ultimately did make it in. It just took some time to make sure that we had the solution that the community felt comfortable with putting in. Another example was the binary JSON format, JSON-B, where the release of that was held up, or the major release of Postgres 9.4 was held up to ensure that we had the on-disk representation correct, because anything to change the on-disk representation of a data type means significant pain in terms of upgrading. So the community wanted to make sure that we got it correct. We were optimized for how it handled compression, and everything was good to go for that release. And I think again, having that ethos is very important. I'll say that there's one feature that I really wish made it into Postgres 11 that did get held up because the community wanted to go through the code more and make sure that it was clean and stable and introduce issues into it. And seeing that dedication, making sure that we have it correct, does it also translates back to the user side, knowing that the Postgres community has its eyes out and for not breaking the functionality or not creating a bad experience for the community. Would be great to have some of those features like pushed out. Yes, of course, but I think people feel much better knowing that they're pushed out correctly and accurately, and that their data is safe and secure on disk. The other thing is, and this is changed a little bit over time. The release process is a little bit more formalized now in the community. Now, the community will say we're going to release things when they're absolutely ready, but it's the fact that we try to make a major release once a year, and that's usually targeted in the third quarter, roughly end of September, early October. And of course, I will give the disclaimer that don't quote me on that. The other thing that's changed in recent years is having regular minor releases that you can go to the website. It's the roadmap page on the Postgres website, and you see that we try to do minor releases once a quarter. We actually have one coming up on August 9th. And of course, if this airs after August 9th, then I will also say we just had one on August 9th. And the minor releases basically are bug fixes and, if needed, security fixes for the software. And by having that regular schedule, it allows DBAs everywhere to plan their updates. Plan if they need anything beyond a basic restart of the Postgres server, they can plan for appropriate downtime. So the last thing is just the dedication of the community too. That it's not uncommon to talk to someone in the community who's been active for close to 20 years. People really love Postgres. People really love contributing to it, and you see this dedication of people continuing to improve it. And sometimes people leave the community, and sometimes people might take a brief hiatus and then come back. Whatever it is, but the community has just always been very supportive of it, and has always tried to put things in place to help ensure people can pick up whatever work they were doing, or be able to start contributing anew whatever makes sense for them.
And one of the things that I think helps contribute to the overall staying power of Postgres as well are the combination of it being open source for so long and the very extensible plugin capabilities that sort of obviate the need to create any long-running fork of the project to add new functionality, where some databases have had forks early in their history that never got merged back in because the added feature set was too incompatible with either the vision of the original project or the code base. Where with Postgres, you can have some very drastic changes to the overall interface and capabilities of the database while still remaining code compatible and only requiring a plugin extension rather than a complete rewrite of the underlying code.
Yeah, and I think and you talk about this extensibility as well. One thing that you touched upon earlier was how much should an application developer, how much of the business logic should an application developer put into an application away from the database versus in the database itself in terms of portability. And the nice thing about Postgres is you kind of have that choice. Postgres has this thing called the procedural language loader, which was originally written to allow you to write Tickle within Postgres. It later was extended to support PGSQL, which is a language similar to PLSQL out of the box, as well as Perl and Python. But people have written other language extensions to Postgres, such as R or JavaScript or Java. So what's interesting is suddenly, you think about it, like I can write Python within my Postgres database. I can put Python within a function and then call that function that's executing, maybe even NumPy or SciPy, and that that adds a lot of that really makes a very interesting calculation in terms of, or an interesting, it gives you an interesting idea for how you want to architect your application. You have to pay a penalty whenever you bring data out of a database over a network connection into an application. You can save a lot on bandwidth and arguably performance by doing some of this work within the database itself. Databases tend to be very I/O heavy. They're reading and writing to disk. They tend to not use as much CPU. So if you want to offload some of your calculations into your database, chances are you do have a lot of CPU available to do that.
Yeah, I've definitely taken advantage of that for doing some ad hoc parsing of XML without having to revert to XPath. I just wrote a Python function and loaded it into the database, and that made my report writing a lot easier.
Awesome.
And one of the biggest pushes in the data layer right now is the desire to enable largely distributed clusters of data stores. So there are projects such as CockroachDB that speak the line protocol of Postgres while being a complete reimplementation of the engine itself. And then there are projects such as Citus, which are an extension to Postgres that add the ability to scale out horizontally for write heavy workloads. And one of the questions that comes up a lot is what plans there might be in the Postgres community to try and incorporate native ability to be able to scale the write workload more horizontally versus vertically scaling a master node and then distributing the read transactions.
Yeah. So I think what you've seen, and I'd say this has probably started with Postgres 9.0, is this push for Postgres to be more of a horizontally distributed database. On Postgres 9.3, something called the Postgres foreign data wrapper was added, which foreign data wrappers themselves were added in Postgres 9.2. Essentially, what a foreign data wrapper is that it allows you to communicate with another, whatever it may be, another database, another file system, and pull that information into Postgres and have it look like a Postgres type query. There's support for Postgres, MySQL, Oracle. You can post things to Twitter from Postgres. And again, like everything in Postgres is extensible, so you can write your own foreign data wrappers. But in Postgres 9.3, the Postgres foreign data wrapper essentially introduced the ability to do distributed transactions in Postgres. If you want, if you open up a transaction on a local server and you're trying to do something on a remote server, it will also open up a transaction on that remote server. Now, I had to do a little bit of research to figure out, where Postgres was in terms of, full support for distributed transactions. And one of the big things that's missing is error handling for certain failure cases where based upon the failure and how things fail, a database administrator might need to clean up transactions on another system. That said, if it's a fundamental failure, like where something goes down on the local, it should be able to safely roll back the transaction on the remote server. So that said, I did hear there is a project in the works for that kind of distributed transaction handling, be able to handle those better error cases, and hopefully it's able to make it into version 12. Additionally, you've seen all this work in Postgres about making it easier to partition. So Postgres has been able to support partitioning for over 20 years, but a big advancement came last year during the Postgres 10 release by supporting declarative partitioning, which is essentially partitioning from, is a partitioning syntax that people coming from other databases are very familiar with. Postgres 11 is significantly expanding on that by making it easier for the partitions to be managed, where they're doing more auto management of how the data can move between partitions, be removed from partitions, be able to push down various indexes between the partitions. So partitioning is going to be much easier to use once Postgres 11 is released, which is again anticipated in the third quarter of this year. So basically, you see a lot of work by the community to make it easier to do all these actions within Postgres, and I think that has been part of the community's mindset shift. Is that while we do try to make Postgres as extensible as possible, and we welcome people to write extensions to it. Once we see that certain functionality should exist within Postgres itself, such as replication, which initially was only handled by extensions, the community will push to get that in, because I think you see this mindset of let's make this as easy for users as possible while maintaining that robustness and that flexibility of choice.
And are there any other aspects of the roadmap of Postgres that you think are worth calling out?
Yeah, I think that there's a lot I'm very excited for. So I'll try and touch on a few projects that I know people are working on for version 12. And again, I don't know if they're going to make it into version 12. The version 12 development cycle just started, but I'll touch on some that I've heard about that I find very interesting. So Postgres in version 11 is going to introduce just-in-time compiling on various types of expressions. So just-in-time compiling will actually help optimize various parts of the queries, such as when you're doing something called tuple deforming, or essentially formatting the tuples from the way they are on disk to what you need to be able to process them within the query itself. Also, in certain places where you're evaluating expressions, such as in the where clause of a Postgres query, or certain things in the select list or the first part of a select statement. I definitely see more improvements to, we're introducing the JIT system in Postgres 11. I'm sure there will be improvements made to it in 12. Another project that's been proposed for 12 is rewriting the executor, which is the part of Postgres that says, all right, either write all this information to disk or pull all this information from the disk and give it off to the user. That system has not been rewritten in a while, and the proposal to help optimize it and make it even faster, it's certainly very interesting, and I'm curious to see what happens with that project. Partitioning will be continue to be improved. I definitely see partitioning being a part of the next several releases, and additionally parallelism. I should say at least read parallelism. I know we're gradually working towards write parallelism, and I understand there are some challenges associated with that. But in terms of read parallelism, Postgres 10 it was introduced in Postgres 9.6, and Postgres 10 made some huge advancements in it, and we have some more coming in Postgres 11. But you'll continue to see this work, presenting itself in Postgres 12. One other project that's really interesting is a pluggable storage layer. So right now, Postgres only has one way of storing information on disk. It's the way that it's a storage engine that's been used now since I don't even know how old it is. It's it's a little bit before my time being involved in the project, but it's been around, I want to say, since the beginning. There's this proposal of a new storage engine called zheap, which is supposed to help with basically, the idea is that it should be an improvement upon the current storage layer, but maybe not necessarily for all applications. We don't know yet. It's very new, and in order to make this really successful, the Postgres community is evaluating introducing a pluggable storage API so people can write their own storage engines and attach it to Postgres. You see this already with MySQL. That's how MySQL was architected from day one. So there's definitely there's some very large projects in the pipeline. One that I'm also interested in is the SQL, the implementation of the SQL JSON standard. So Postgres does have a lot of functionality for interacting with JSON documents and running queries over them. The SQL JSON standard provides the way that the SQL committee is recommending for all of these to be implemented, and search over, introspect, and have standard functions around it. So that project was proposed late in the Postgres 11 development cycle. So people are iterating on it for version 12, and we'll see if if it does make it in.
And are there any other aspects of Postgres that we didn't touch on, which I know there are many, which you think we should cover before we close out the show today?
Whew. Well, let's see. Let's see what I can do there. So security. I'll touch on security real briefly. Security has always been an important part of the Postgres project as well, making sure that you can securely connect to the database, securely store your data, and ensure people, only the people who have access to do reads and writes or various administrative level functions can do that. I could talk about the access control system, which you can commonly think of a grant and revoke. That is probably an 8-hour talk in itself. Authentication is something I will touch on, though. Postgres has a lot of different authentication methods, from trust, which you should only ever use in your development environment, because if you set trust, as soon as you set trust, people can access your system entirely, to more advanced enterprise type authentication controls, such as the GSS API or the SSPI, which is the Windows-based one, LDAP, certificate-based authentication, enforcing. There's even a verify full mode where you have to ensure all the certificates being used are valid by the certificate authority. Postgres version 10, we introduced the Scramshaw 256 authentication as a way above the MD5 authentication system that we had in place. Postgres 9.5 also introduced something called row-level security. Postgres had column-level security for a while, but being able to control secure access based upon who or what or whatever your policy says about a row was added then, and continued to be improved upon as well. I guess the last thing I touch upon briefly, I'll talk about full text search. So Postgres does have full text search out of the box. In Postgres version 11, we're going to be able to support stored procedures out of the box. So Postgres was able to support stored functions, but stored procedures give users the power to create and roll back transactions within a function itself. That's a feature that's been people have wanted for a very long time, and we're excited that's going to finally be rolling out.
So, for anybody who wants to follow you and get in touch or see, follow the work that you're up to, I'll have you add your preferred contact information to the show notes. And as a final question, from your perspective, what do you see as being the biggest gap in the tooling or technology that's available for data management today?
So, of course, the tooling technology is going to continue to improve. I would almost flip it that I still think it's awareness and education. I was fortunate. I decided to study computer science when, it was right after the dot-com crash. So it was a little bit of a taboo field to go into then. Now it's great. It's a very popular field. I'm happy to see it, but you still see that a lot of these code academies, which are helping people get jump started in the world of software engineering, they tend to focus on particular topics in web engineering, quite often front end web engineering or data science, but you don't really see many that do data management as a whole. And part of it is that it's probably hard to do to study data management in a 12-week boot camp, let alone in a 4-year major, because there's just so much involved in it, and it's a little bit of a harder skill to learn, but I think a very necessary one. And I would encourage people to study more around it because as you might have heard in this podcast, there's various aspects that you can that you can learn and get involved in there. So I think just to bring it back around, I do think it's an awareness problem and an education problem, and I'm happy. One of my goals as part of the Postgres community is to help make working with databases more accessible.
All right. Well, thank you very much for taking the time to join me today and talk about the work that you and the community are doing on the Postgres project. It's definitely a very useful and valuable project and database that I have used many times. So thank you all for that, and I hope you enjoy the rest of your day.
Sure. Thank you, Tobias. I'll definitely pass on your kind words to the community. Thank you so much again for having me on.